right, everybody. We are the Interactive Airplane Model Simulation Team. I'm Miles. This is
Pedro.
I'm Charlene.
David.
So, for some background, we worked with a company called Pacific Miniatures, or Pac-Man, and they are a scale model aircraft company who makes, they're based in Fullerton, and they do model airplanes for display for like Boeing and other aircraft for over 70 years. And what our task was, in collaboration with the mechanical engineers, was to make a model that's more interactive, that would be more visually appealing for market showrooms, things like that. So the hardware and software we used were, we used an Android tablet for our app. We used NEMA 23 step motors. These, there's 6 of those. For the drivers, there's Step Online BM542Ts. We have 2 220 volt, 20 amp power sources underneath there. You'll be able to see the internals in a minute later. Starting off with it's running with an Arduino Mega, some basic micro servos. We have MG996R servos, which are these. We have 5 of those in the plane, and we are connecting to an HC05 Bluetooth module for the app. And the software for the app was, we originally were using MIT App Inventor, but that didn't really go as planned, so we switched over to Android Studio, and of course we're using the Arduino IDE.
Okay, so I was in charge of the motion platform, which is that platform at the bottom. Ooh. Stand there with it. We had a lot of problems working with mechanicals because, like our previous group mentioned, we had to wait for a lot of the parts.
Time was a big issue.
We waited a long time for those rods, so we didn't actually have a prototype platform until the end of last semester or beginning of this semester. We got together during the break to kind of work on it and to kind of get a lot of the stuff working, kind of. But the first prototype that we had, we had one set of drivers first, which was the PM298 or something, the little red ones.
Yeah,
that
the
everybody has.
L298.
Yeah, L298.
Some of the other groups.
They did not work as well as we wanted. They didn't provide enough power to the platform, and so whenever we put just a simple cardboard tube, the platform would actually collapse on itself. We then switched to these drivers. It provided more than enough current, but there was still that issue of when we cut the power to the platform itself, the weight of anything on there would still bring everything down, which was a problem. We had it off while it was over there, and it was holding the weight fine. Another problem with the platform that Pac-Man made a note of at the ECS showcase was the fact that the rods were a little long, which also contributed to a lot of yeah, so on the left there is the long rods. You can't really see the difference, but it's actually a pretty big difference. They added to a lot of instability with the motions. So whenever we try to do anything revolving around like rolling or yawing with the plane, it would twist and almost break. So after the ECS showcase, they broke off the arms and then they sawed off a good chunk of it. And now it's a lot more stable. Let's stop. Sorry about that. That's a sponge.
So I'm in charge of the landing gears. So it basically replicates the linkage assembly, simulate takeoff and landing procedure. We basically just use servos, servos for the landing gears and one servo for each door. It just rotates 0 to 90 degrees for the door to open and close and the wheels to go down and up.
Yeah, unfortunately, on the way here, the doors kind of broke on us, so we won't be showing you the landing gears working today, but we do have a demo of those working, so just as a second. Also, another problem we had with the servos for the landing gear is their angles are kind of inconsistent, or mechanicals, when they put the servos in, put the servos at inconsistent angles, so we had to have different numbers in the code for servos that were supposed to be doing the same thing simultaneously. So that was a pain in the butt. So we're just doing a little initialization.
Yeah, before we had a very big problem with when we were running anything, we couldn't leave it alone, or I feel like we aged a couple years on this project. It's also worth noting that we got this project kind of by luck, by chance. We thought we were going to build a plane, like to fly it, but we got a platform stand here. I'm gonna have it fly by itself. Whenever it wants to. While I fix this, he will talk about it. Yeah.
Hi. So the app was built using Android Studios. I originally wanted to do it using the MIT App Inventor, but we found that it's way too limiting. And for what I wanted to do, it wasn't really easy to implement. So I decided to switch to Android Studios upon recommendation of a dear friend. Yeah, so right now we have two different apps. One for manual control, which in this kind of sense is optimal because it's for a company, and they want to have a certain app just for them to calibrate, not let anybody use it. And then there's a mode where everything's already preset, so it has different commands and so on.
And these are some of the things we've been dealing with for the past semester.
And let me
That
just
was not happening earlier, by the way.
switch the camera yet. Show them that. Yeah.
This is why you take videos of it working.
Hey, where's the webcam?
Very
Oh,
well.
Okay, so this is the, let me see. You guys can see this. This is the main app. We have all different commands: yaw, roll, the wheels down, pitch up, pitch down.
so this is just a picture of the plane, and we have buttons on the top, bottom, left and right, and we have controls for the turn, and for landing gear controls, and stopping it, and the custom flight lines as well.
We also have, and of course, it wouldn't be a good project without a mandatory
Special thanks.
special thanks to Dr. George.
We actually have two apps, mostly because we couldn't get 2 pages to work. One is the flight controls and like the pitches up and down, you'll roll left, and one of them is more for like manual control. So these letters have them set to specific commands for pairs of motors. Hackman actually wanted individual motor control, and while that was good and fun, it actually proved to, again, scare the crap out of us, because if we move one motor too far, the whole thing kind of twists. Right, so that was the prototype. Everything was kind of out in the open, and Hackman didn't really, they wanted it to be really neat so that they could have it in a showroom to demonstrate. And
So they pretty much just got moved underneath.
yes, so this is what it looks like underneath. The two controllers over here splice through a single power cable, and all the drivers are lined on the side there.
Drivers on the side. Here's the Mega, here's our Bluetooth module, and just all the different crazy routings.
Ah, and because we're kind of, turn off this. Because we're kind of scared of it failing here, we're gonna play the videos that we took yesterday.
But actually working properly.
At 2 a.m.
So this is just a side and front view of the custom flight plan. It's doing a pitch up, and it does a pitch down, and then it does rolls, and also yaws. Yeah, just do it double speed.
Yeah, we set the code to make it go slower because the company wants it a bit slower for demonstration purposes, but if you want to make it go faster, you could.
So there's roll left, coming back, to the roll right. Honestly, I took the motion platform because I thought it would be the easiest, but it proved to be a little more challenging. And then it's coming back. And I keep thinking it's done, but it's not done. And that's a front view. I mean side view. This is a front view.
Yeah, in this view you can see the rolling a lot clearly. A lot more clearly. So it rolled to the left, and then it went back, and then rolls the other direction. And
Yaw.
that's the yaw. It's basically a lateral movement to the side, comes back to the center, and then goes the other direction.
And then this
Lastly,
is the landing gear.
we sampled the landing gears actually. So pretend that Red Cup is a wheel. The tracks back into the plane.
There should also be a door there. We had to cut those rods there because they were getting in the way.
That's
They opened up, and
how it
then
would have functioned if it didn't break on the way here. So that's
it.
Questions? Yes.
Sherman or me?
He's the best.
He's the question.
All right, thank you. All right, thank you.